Hello and welcome back to the Power BI channel. And in this video, I'll be going through the advanced level, or probably intermediate level transaction queries in SQL. And this is the part of the Transact SQL training, where in the beginning session we covered the select statement and all the other statements that we start off with with querying the database as well as the connecting and viewing multiple tables together. But in this section, we will be going to a next level by creating a views, tables, as well as creating queries using common table expressions, as well as writing queries that use derived tables. So let's get started. As you can see, we've been using AdventureWorks database. So we'll be continuing to use that in Azure Data Studio. And as you can see that we have connected Azure Data Studio with with querying the data from the product itself. And if I try to, just execute this product with product, for example, let's go and check. Let's limit this columns, like for example product ID. Sorry, yeah, there you go. Product ID, name, and list price, and where product category ID equals 6. If I execute this will give us some limited columns like product ID, name, and list price. And we want to make sure that next time we don't need to type these uh, all the columns and remember all the columns in that. So in creating some view of this particular thing, so that we just need to just call and run the view. What we can do is, let me give a heading here, creating views. And now what we'll do is we'll modify this code to add a create view clause. And from that, from this particular thing, what we'll do is we'll just use create view. And in the same schema, sales lt dot view product cat 06. This is not a fancy name, but we can give a name. For example, the category of the bikes, like this is for example road. So what you can do is we can give road, and then we'll write as, and then we'll use this query and run this. So what we'll do is we'll run this query, and the saying command completed successfully. This means that in the database we have created a view here. So it will not show up in the table, it will show up in the view section. And this view v product road is there. So now we'll do is we'll just query that view. So for example, select star from sales lt dot v, and now it will come up as v product road. And if I select and execute it, it will show me the exact same query. If I run both the query and the view in the same way, it will show me the same number of records. Now, as part of the, what do you call it, let me run this. As part of the, since we've created a broader view, we can also apply filter here by saying where product, where product list price, like list price is less than 1,000. So in this way we will be able to further slice and dice the query. So it is returning me 16 records. However, this was in originally returning 43 records. So now what we have used is we have used the query to as a view. We have queried a view as a source data, and then this means we can filter and slice and dice the view as well, and we don't need an extensive query to fetch the records there. So next up we'll use is the derived tables. So let me give my heading, using a derived table. So sometimes you might end up having, build up complex queries. You can use derived table in place of those complex queries to avoid adding it, becoming more complex. So basically, derived table is just um, a sub query, you would say, and then based on that we can just uh, look for retrieving more records in it. So consider what we'll do is we'll use the same query, the first one, select, and here, so instead of a list price we'll use a case statement here. Oh, sorry, we'll add another column calling a case statement, case when list price is greater than 1000, then high, else, and sorry, normal. So we are just categorizing the price and as price type. So let's run this. I'll remove this condition. I'm just running this query. So it's saying high, normal, high, and all the stuff is here. So now it is just calculate whether the price of a product is considered high or normal. Now, if you want to further build on this query based on some additional criteria, and so without adding to its complexity, what we can do is we can just you know create a derived table, uh, which is a kind of a view defined, or a subquery that is defined, and we can query that based on the derived table. So for example, what we'll do is we just need to filter. The goal is to filter all the high products. So what we will do is we'll just copy paste this, and on top of it we'll just open close parenthesis just in case to see, and write from clause, and then we'll just save this as dt dot price type. Sorry, um, we'll just give this name as dt, and then we will use a select query on words, select dt dot product id, and when you type dt, all the columns comes in, product id, dt dot name, and dt dot list price, and then we'll apply a filter where dt dot price type is equal to high. After that, what we'll do is we'll run this query, and see, this is showing all the high prices. So this derived table fetches product id, name, and list prices of the product, and which the price type is high only. So what we've done is we've derived a table enable us to easily build on top of the initial query, and I mean, without making any complexity in the initial query. This is just a simple example, but we can put all the multi-line query level codes to the this query. Since this topic covers creating table views and temporary objects, we will also start off with moving on to create a table as well. So creating table, and then what we'll do is we will make sure to use the appropriate database. So that is the first command, and then we'll use create table product 2. So for example, this is product 2, and then what we'll do is we'll open parenthesis product product ID. We'll give the data type, and then we'll say that this is the primary key and not null. Second one, we'll give name. Let's give prod name varchar 50, and this is also not null. And desc description varchar max, and this is also not null. So this is it. We've used the AdventureWorks database, and we have used the create table query to see what is the effect. Let's run this. Command completed successfully. And if you see here, there will be, if we refresh it, DBO product 2. So this is under the DBO schema because we haven't specified a specific a schema in that. So otherwise we would have just mentioned sales LT. It would be moving towards it will be storing against sales LT schema. So what it has created is, it has created, let's see. So this is product ID, which primary key, which an integer type. This is not null. Product name varchar, product description varchar max. So in order to create a table, you must have a create table permissions as well as an alter schema permissions as well. Like because if you don't have permissions, then the view only, you cannot be creating table. So once we have created a table, then we have to populate the data as well. We can also use the transact SQL to populate the data. We're using insert query. So insert product, and this is the table name, and then we'll use product ID, product name, and description, and then we'll use values 1 comma test comma testing. And we'll run this query, and if you see here, it shows, sorry, I've used single. I should have used single quote. So this is and there you go. If you run this query, it will be affecting the rows. And if I checked select static from product 2, and DBO is by default, so this is the data inserted. So next what we'll do is we'll use temporary tables. So temporary tables are just created tables on the go, and we'll be able to there are two aspects where we can use temporary table is to just fetch some values temporarily and then move it further. um, it is just on the current session that the table is created, and when the session is over, it is no longer existing. um, yeah, and then what else? This can be created, the naming convention needs not to be what you call it, consistent. We can use any names, multiple names, duplicate names as well, because this is created on a local temporary environment. There are also things that we can create a global temporary table where which can be accessible through all session, whoever is accessing the database temporarily. But that is the what do you call it, it's just the temporary table that is created on the current session, and we can recall it and then drop the table based on that. It is just simple as the table that we created, and it's in. I'll just copy paste this. So instead of a normal table name, I just need to put a hash sign here, and I'll just for the reference will put up a temp name as well. So if I run this, this will be created. This will be created, and yeah, this is it, and we've created a local temporary table where we can insert values, where we can fetch all the details about it. Next, we will move on to common table expression. The common table expression, or CTE, it provides you a mechanism for you define subqueries that have been used elsewhere, like a query. So it's unlike the derived table, because a CTE is defined at the beginning of the query and maybe referenced multiple times in the other queries within. So so basically, what we'll do is we'll define an expression, and then it generally breaks down the query problem into smaller and modular units. And so because it is the entire scope of the query is limited, so what we can do is we can just use common table expression, um, uh, which are in order to break down the query. And it is just a temporary lifetime of the CTE. So when an outer query is executed successfully, the entire CTE lifetime ends. So this is very handy to break down a big query, and filter out the query, a complex query, to retrieve information there. So this starts with, so I'll just go to here. Let's start with clause, and CTE name is the name. CTE, let's give him CTE 01, and then as, and then we'll define, for example, select air order date from sales LT dot order, sales order detail. I think the order date is something, order detail, sorry. Let's check this query. Yeah, here it has order date, so we are just fetching order. So it's just fetching order date, and so this is a bracket. So the CTE1 is this, and now what we'll do is we'll use an outer query, select order air. Sorry, I'll give a name to it as well, order air, and then we call it order air. So on account, uh, customer order ID, you would say. So if we run this, we'll be able to group by, we are able to apply group by in the outer query, and then this outer query is executed based on the input of the query. So this is a simple CTE that we define an expression and then call that expression to further slice and dice. So when writing the CTE, consider some of the guidelines that. So first thing is, unlike the derived table, a CTE may be referenced multiple times within the same query with one definition. Multiple CTEs may also be defined within the with clause. Like, if you want to do that with CTE 01, with CTE 02, something like this. And this support recursion as well. in which the expression is defined with a reference to itself. So this is it from this section. So we have created table views and temporary objects, and we also used common table expressions in that to write the basic manipulation of the queries and creating some of the